Hello grade 6, how are you today? I hope you are fine. Today we are going to study solving the first degree inequality in one unknown. But before we start, we have to know that, like the equations, the inequalities also have some properties. The first one for the addition. The same number can be added to the both sides in inequality without changing the solution of inequality. For example, if we have x minus 2 less than 3. To solve this inequality, we have to add 2 to the both sides in inequality. So the left hand side equals x minus 2 plus 2, and the right hand side equals 3 plus 2. 3 plus 2. Negative 2 plus 2 equals 0. So the left hand side equals x, and the right hand side equals 3 plus 2. 3 plus 2 equals 5. So in the set of integer numbers, the solution set of this inequality equals all numbers less than 5. All numbers less than 5. So the solution set of this inequality equals the set of 4, 3, 2, 1, and so on. The second probability for the subtracted. The same number can be subtracted to the both sides in inequality without changing the solution of inequality. For example, if we have this inequality, x plus 4 is greater than 5. X plus 4 is greater than 5. So we need to subtract the number 4 from the both sides. So the left hand side equals x plus 4 minus 4 greater than 5 minus 4. 4 minus 4 equals 0. So the left hand side equals x, and 5 minus 4 equals 1. So the right hand side equals 1. So the solution of this inequality equals the numbers is greater than 1. Numbers greater than 1. So the solution set of this inequality in the set of integer numbers equals the set of 2, 3, 4, 5, and so on. And the third property for the multiplied. The same positive number can be multiplied to the both sides in inequality without changing the solution of inequality. But notice that only the positive numbers. Only the positive numbers. Only the positive numbers. For example, if we have x over 3 more than 2. To solve this inequality, we need to multiply the both sides by 3. The both sides by 3. So the left hand side equals 3 times x over 3. 3 times x over 3 equals x. And the right hand side equals 2 times 3. And 2 times 3 equals 6. So the solution of this inequality equals all numbers greater than 6. So the solution set of this inequality equals the set of 7, 8, 9, and so on, and so on. The fourth one for the divided. The fourth one for the divided. The both sides in inequality can be divided by the same positive number without changing the solution of the inequality. For example, if we have 3x less than 9, 3x less than 9. So we need to divide the both sides by 3. The both sides by 3. 3x divided by 3 and 9 divided by 3. 3x divided by 3 equals x, and 9 divided by 3 equals 3. So the solution of this inequality equals all the numbers less than 3. So the solution set in the set of integer numbers for this inequality equals the set of 2, 1, 0, -1, -2, and so on, and so on. But notice that we have a difference between the inequalities and the equations in multiplied and divide. In equations, the both sides can be divided or multiplied by the same number without change the solution of the equation. But in inequalities, we can divide it and multiply the both sides by a positive numbers only, without change the solution of the inequality. So what happened if we multiplied or divided the both sides in inequality by negative numbers? Let's show this. The fourth property, if we multiplied or divide the inequality by a negative number, we have to reverse the inequality. For example, if we have this inequality, -3x is more than 6. So we need to divide the both sides by -3. -3 divided by -3 equals 1. So the left hand side equals x. 6 divided by -3 equals -2. And now we should reverse the inequality. So the solution of this inequality equals the numbers less than -2. So the solution set of this inequality in the set of integer numbers equals the set of -3, -4, -5, and so on. By the same way, if we have this inequality, -x over 2 greater than 4, -x over 2 greater than 4. So we need to multiply the both sides by -2. So the left hand side equals -2 times -x over 2 greater than 4 times -2. -2 over -2 equals 1. 1 times x equals x. So the left hand side equals x. And the right hand side equals 4 times -2. 4 times -2. So 4 times -2 equals -8. And now we should reverse the inequality. So the solution set of this inequality in the set of integer numbers equals the numbers less than -8. So the solution set is the set of -9, -10, -11, and so on. And now let's try to solve some exercise. Find the solution set of the inequality 3x plus 5 less than or equal to 40, where a, x belongs to the set of integer numbers, b, x is belong to the set of natural numbers, and represents the solution set on the number line in each case. In the beginning, let's start with solve the inequality. The inequality equals 3x plus 5 less than or equal to 14. So we need to subtract 5 from the both sides and divide the both sides by 3. Divide the both sides by 3. So we start with the subtracted. The left hand side equals 3x plus 5 minus 5, and the right hand side equals 14 minus 5. 5 minus 5 equals 0. So the left hand side equals 3x. 14 minus 5 equals 9. So the right hand side equals 9. And now we should divide the both sides by 3. 3 over 3 equals 1. So the left hand side equals x. 9 over 3 equals 3. So the right hand side equals 3. So x is less than or equal to 3. In the set of integer numbers, the solution set of this inequality equals 3 and all the numbers less than 3. 3 and all the numbers less than 3. So the solution set of this inequality equals the set of 3, 2, 1, 0, -1, -2, and so on. And now we need to represent this solution set on the number line. We have 3, 2, 1, -1, 0, -1, -2, and so on. So the solution set on the set of integer numbers starts from 0 and so on in the negative numbers, and so on in the negative numbers. And now what about the set of natural numbers? The set of natural numbers not contains the negative numbers, so we have start from 3 and go to 0. So the solution set of this inequality and the set of natural numbers equals 3, 2, 1, and 0. So if we need to represent this solution set, 3, 2, 1, and 0. 3, 2, 1, and 0 is the solution set of this inequality in the set of natural numbers, because the set of natural numbers not contains the negative numbers. And now let's start with the second part of our lesson, the value of x between two integer numbers. The value of x can be written between two integer numbers like one of these forms. Number 1, x greater than 1 and less than 4. Greater than 1 or less than 4. So x here is greater than 1 and x less than 4. So the value of x is all integer numbers between the number 1 and the number 4. So the solution set of this inequality equals the set of 2 and 3. 2 and 3. The second form, x is greater than or equal to 2 and x is less than or equal to 5. So x here is greater than or equal to and x less than or equal 5. So the solution set of this inequality equals all the numbers between 2 and 5, and we take the number 2 and the number 5 because we have equality sign. So the solution set of this inequality equals the set of 2 and 5 and the numbers between 2 and 5. So we have also 3 and 4. The third form, x is greater than or equal to 3 and x less than 6. So x is greater than or equal 3 and x less than 6. So the solution set of this inequality equals the set of the numbers between 3 and 6. And we take the number 3 because we have equality sign. So the solution set of this inequality equals the set of 3, 4, and 5, because we hasn't equal signs like the previous example. So the solution set of this form equals the set of 3, 4, and 5. The last form, x is greater than 2 and x is less than or equal to 6. So we have x greater than 2 and x less than or equal to 6. So the solution set of this inequality equals the set of numbers between 2 and 6, and we take 6 because we have the equality sign. So the solution set of this inequality equals 3, 4, 5, and 6. By the end of the lesson, study hard and stay safe. Good luck.